Welcome to Physical Sciences Consultorium. This video is part of the series How We Know the Universe. In this episode, we take up a question that sounds simple, but turns out to be surprisingly subtle. How do we measure distance in space when we cannot travel there? In space, distance does not reveal itself easily. A nearby object can appear faint. A very distant object can appear bright. Size, brightness, and distance are deeply entangled. This means distance cannot be guessed from appearance alone. It has to be inferred carefully. Even in everyday life, you rarely measure distance by touching things. You judge distance using perspective, relative motion, and comparison with familiar objects. So the idea of indirect distance measurement is already something you understand intuitively. One of the most reliable ways to estimate distance is to observe how an object appears to shift when the viewpoint changes. Nearby objects seem to move more. Distant objects seem to move less. This apparent shift is known as parallax. You can see parallax for yourself. Hold your thumb at arm's length. Close one eye, then the other. Your thumb appears to jump sideways relative to the background. That sideways jump is parallax, and it immediately tells you that your thumb is close. Parallax is not a visual illusion. It is a consequence of simple geometry. The amount of shift depends only on two things: the separation between the viewpoints, and the distance to the object. Nothing else enters the calculation. Astronomers apply this same idea using Earth itself. As Earth moves around the Sun, our position in space changes continuously. This change in viewpoint allows astronomers to observe tiny shifts in the apparent positions of nearby stars. Stars that are closer to us show a larger parallax shift. Stars that are farther away show a much smaller shift. And stars that are extremely distant show almost no detectable shift at all. Distance is encoded directly in how much an object appears to move. Parallax is extremely powerful, but it has a natural limit. As objects become more distant, the shifts become extremely small and eventually fall below our ability to measure them. At that point, geometry alone is no longer sufficient. Once distances to nearby stars are measured, those stars become reference points. Astronomers compare them with similar objects farther away. In this way, distance measurement is extended gradually, from nearby space to more distant regions. Distance estimates are never accepted in isolation. They must agree with observed brightness, with motion, and with known physical behavior. If these checks do not agree, the distance estimate is revised or rejected. This is why measuring distance in space is not guesswork. It combines geometry, motion, and physical consistency. Each method supports the others. Astronomers do not measure distance by traveling. They measure it by reasoning carefully from changing viewpoints and stable physical laws. Simple ideas, like parallax, are repeated and extended across the universe. If this way of understanding space science is useful to you, this is exactly what Physical Sciences Consultorium exists for. We focus on how scientific knowledge is built. If you found this episode helpful, please like, share, and subscribe to the PSC channel.